Okay, we're doing example 2, section 3.4. So this one says, this is example 2. So we want to find, for this function, f of x is equal to x squared plus 2x. It says that we want to find the slope of the secant line through the 2 points, the points where x equals 3 and x equals 5. So slope of the secant line, if we remember what that is, the secant line slope is defined to be f of b minus f of a over b minus a, where in this case b is going to be 5, so f of 5 minus f of 3 over 5 minus 3. So we need to find f of 5 and f of 3. F of 5 we can find plugging 5 into the function, so we're going to get 5 squared plus 2 times 5. That's 25 plus 10, that's 35. F of 3, the other one, is going to be 3 squared plus 2 times 3. So that's 9 plus 6. 9 and 6 gives us 15. Okay, so now we can plug that into the formula and get the slope of the secant line. Slope of the secant line is going to be f of 5, which we just said was 35. So 35 minus f of 3, which we just said was 15, divided by 5 minus 3. So 35 minus 15 gives us 20. 5 minus 3, 2. So the slope of that secant line is 10. Then it says, find the equation of the tangent line through the point where x is equal to 3. All right, so for that one, the slope of the tangent line, the equation for that is the limit as h approaches 0 of f of, it's f of x plus h, but in this case we're actually looking for what's the slope of the tangent line when x is 3. So we'll just go ahead and put f of 3 plus h minus f of 3, and then we'll divide this by h. So that's the equation for the formula for the slope of the tangent line at any given x value. In this case, we're looking for it at x equals 3. So now we need to find f of 3 plus h. Oops. Now let's just do this. F of 3 plus h. So that's going to be whatever we get when we plug in 3 plus h for that. So that'll be 3 plus h squared. So I'm plugging in 3 plus h for the x here and here, plus 2 times 3 plus h. So if we simplify that, 3 plus h squared, remember that to square that you'll have to write it twice. 3 plus h times 3 plus h, and then you do FOIL on that, and you should get 9 plus 6h plus h squared. So that's that term. For the second term, this one here, we'll just distribute the 2, and we'll get 6 plus 2h. Okay, and then f of 3, we already found f of 3, right? That was 15. So if we put these things together, we'll get the slope of the tangent line when x is equal to 3. It's going to be the limit as h approaches 0 of, this is f of 3 plus h. And actually, let's go ahead and just simplify this a little further. We got a couple like terms here. 9 plus 6 is going to be 15. I'll write the h squared term first. We get 6h plus 2h, that's 8h. And then we have our constants. 9 and 6 is 15. Okay, so f of 3 plus h is what we have over there. So that's h squared plus 8h plus 15. So that's f of 3 plus h. Now we have to say minus f of 3. And again, I'm looking at that formula here. These three parts here are f of 3 plus h minus, and then we have f of 3, which we saw already was 15. So that's what we get. Again, the first 3, that's f of 3 plus h. That's f of 3, following that formula. Okay, so then this is the limit as h approaches 0. Now look what happens here. The 15s are going to cancel. 15 minus 15 is 0, so those are just going to go away. What we have left then is h squared plus 8h, so we can actually factor an h out of what we have left, and we'll be left with h plus 8. And then we'll have this over h, and those h's will cancel. And then at that point, once the h's cancel, we're only left with h plus 8. If I plug 0 in there, I'm just going to get 8. So the slope of the tangent line is 8. Now this is actually asking for the equation of the tangent line. So that's the slope. So we know that since it's a line, so the tangent line, I'll go ahead and write this equation of tangent line. We know that it's going to have the form y equals mx plus b because it's a line. So lines have that form. That's the slope of our line. So we're going to have y is equal to 8x plus b. Now the question is, well, what is b then? What's the y-intercept of this particular tangent line? Well, the way that we can find that is we know that the function has to pass through the point 315. So the function that we started with, f of x, passes through the point 315. And so does the tangent line, because the tangent line touches the function at that one same point. So the tangent line and the function both go through that point. That tells us that in order to find b, I can plug in the y value 15 and the x value 3 into here, and then I can find b. You can also do this using the point slope form of a line if you remember what that is. So anyway, 15 for y is equal to 8, and then we've got 3 for x plus b, and notice now b is the only unknown quantity here. So we can solve this for b. That's going to be 15 is equal to 24 plus b. And if I subtract 24 from both sides, I get b is equal to 24 minus 15 is 9, so the other way around is minus 9 is our y-intercept for this function, or for this tangent line. So the tangent line then is going to be y is equal to 8x minus 9. And I would like to show a little bit about what's actually going on as far as the graph is concerned here. So I'm kind of out of space here, but maybe I can just squeeze it in up here. Hopefully this will show up. So if we can just picture what this graph is going to look like. X squared plus 2x is going to be kind of like a parabola. I don't know if this is going to show up. Let's see if I can make it work. Okay, so there's the xy axis. This is a parabola opening up. It's got a couple of x-intercepts, one at 0 and one at 2. So maybe here and here. Parabola's opening up. And so what we just found was the slope of the tangent line at 3. So maybe 3 is like right here. So if I were to try to draw a tangent line right here, the equation of that tangent line would be y is equal to 8x minus 9. And that looks reasonable because this this tangent line is pretty steep, so it's got a pretty big slope, 8, and it looks like if that were to continue down, it would intersect the y-axis kind of far down at minus 9. So anyway, that's what the tangent line does. That's what it looks like if you were to graph it. I hope you can see that up there. Anyway, so that's the idea. If you want to find the equation or the slope of a secant line, do this. If you want to find the slope of a tangent line, you use the limit of pretty much the same thing. And then once you've got that slope, then you can figure out what the equation of the line is by realizing that the line has to pass through the same point as the function it does at the x value you're looking at. Okay?